Unit IG2 Risk Assessment. Element 5 focuses on ensuring both physical and psychological health within the workplace. Upon completing this module, participants will gain an understanding of various health effects linked to occupational exposures. They will be equipped to outline the repercussions of noise and vibration exposure, along with implementing suitable control measures. Additionally, participants will comprehend the health effects associated with both ionizing and non-ionizing radiation, implementing corresponding control measures. The module covers the identification of causes of work-related mental ill health and offers insights into effective management strategies. Participants will also grasp the risk factors related to workplace violence and be adept at implementing appropriate controls. Lastly, the module addresses the effects of substance abuse on health and safety at work, providing measures to reduce associated risks. Element 5.1 Noise. Noise level refers to the measure of the intensity or loudness of sound in the environment. It is typically expressed in decibels, dB, a logarithmic scale that quantifies the relative loudness of sounds. Noise levels can vary widely, and exposure to elevated or prolonged levels of noise can have adverse effects on human health, including hearing damage, stress, and other physiological and psychological impacts. Monitoring and controlling noise levels in various settings, especially workplaces, is crucial to ensuring the well-being and safety of individuals. The human ear is a complex and intricate sensory organ responsible for the detection and processing of sound. Divided into three main parts, the outer ear, middle ear, and inner ear, the ear works in harmony to convert sound waves into electrical signals that the brain can interpret. The outer ear captures sound waves through the visible portion called the pinna and channels them into the ear canal. In the middle ear, the eardrum vibrates in response to these sound waves, transmitting the vibrations to three small bones, ossicles, known as the hammer, anvil, and stirrup. These bones amplify the vibrations and send them to the inner ear. The inner ear, housed within the bony labyrinth, contains the cochlea, a spiral-shaped organ filled with fluid and sensory hair cells that convert the vibrations into electrical signals. The auditory nerve then carries these signals to the brain, allowing us to perceive and interpret the wide range of sounds in our environment. The intricate structure of the ear enables us to experience the richness and diversity of the auditory world. Now, let's look into some of the definitions of key terms. Noise. Unwanted sound that may cause disturbance or harm. Sound pressure. Local pressure deviation from ambient atmospheric pressure caused by a sound wave measured in pascals PA. Intensity. The amplitude and intensity of noise are determined by the number of pressure changes in the sound. Frequency. Perceived by the listener as pitch or tone, measured in cycles per second, Hz. Decibel, dB. Unit of measurement for the intensity of sound. dB, A. Noise measurement scale, adjusted to match human hearing sensitivity. dB, C. Noise measurement scale, designed to be accurate for impulse noise. Action level. The permissible level of exposure that is non-harmful for an average 8-hour period. Exposure to noise can lead to various health effects, including tinnitus, ringing or buzzing sound in the ears, fatigue, stress, noise-induced hearing damage, and impaired ability to hear approaching vehicles or alarms. A noise assessment aims to identify workers who are exposed to specific noise levels and determine the duration of their exposure. The primary objectives are to provide the employer with a comprehensive record of this information, and to implement appropriate measures to control and mitigate exposure to noise. This assessment is crucial for ensuring the health and safety of workers by identifying areas where noise control measures are needed and establishing a baseline for monitoring and managing noise-related risks in the workplace. Various types of noise meters are available for noise measurement purposes. Simple sound level meters. These meters measure instantaneous noise levels and are suitable for spot checks or straightforward surveys. Integrated sound level meters. They are designed to measure noise over a specific period. These meters provide a time-weighted average over the designated time frame. They are commonly used for comprehensive noise surveys. Dosimeters. Worn by workers, dosimeters are integrating sound level meters that offer a measure of personal noise exposure. They are particularly useful in work areas where individuals move around frequently, providing a more accurate representation of an individual's exposure over time. Noise control methods are implemented to effectively manage and minimize noise levels across different facets. One approach involves addressing the noise at its source. This can be achieved through substitution, where noisy equipment is replaced with quieter alternatives, or through regular maintenance practices that ensure machinery operates at optimal, quieter levels. Modification of processes is another strategy, adjusting how tasks are performed to reduce noise emission. Additionally, the installation of silencing devices directly on the noise source can contribute to a significant reduction in sound output. Another set of noise control strategies focuses on interrupting the transmission pathway of noise. Insulation involves using barriers or enclosures to impede the transmission of noise, while isolation physically separates the noise source from its surrounding environment. Absorption techniques leverage materials that absorb sound energy, minimizing reverberation and transmission. Lastly, protection for the receiver involves measures such as providing hearing protection, such as earplugs or earmuffs, and implementing health surveillance programs, like regular audiometric testing to monitor and safeguard the hearing health of individuals consistently exposed to noise. These multifaceted approaches contribute to creating a safer and healthier acoustic environment in various settings. Hearing protection is a crucial element in noise control to safeguard individuals from excessive noise exposure. Earmuffs, designed to fit over the head or attach to a safety helmet, provide a physical barrier that reduces the transmission of noise to the ears. They offer effective protection by creating a seal around the ears. Earplugs, on the other hand, are inserted into the auditory canal to form a tight seal, blocking or attenuating incoming noise. Both earmuffs and earplugs come in various designs and materials to suit different preferences and work environments. Choosing the right type of hearing protection is essential to ensure optimal effectiveness and comfort for individuals exposed to potentially harmful noise levels. The selection of hearing protection involves considering several key factors. Comfort and fit are crucial to ensure that individuals are inclined to wear the protection consistently, promoting its effectiveness. Regular maintenance and care are necessary for the longevity and reliability of the hearing protection. Providing adequate training, information, and clear instructions on the correct use and care of the protective devices contribute to their optimal performance. When issuing hearing protection to visitors, hygiene issues should be taken into account, emphasizing the importance of cleanliness. Personal choice is a factor to consider, as individuals may have preferences for earmuffs or earplugs based on their comfort and effectiveness. The overall noise reduction provided by the selected hearing protection is a critical factor in determining its suitability for specific work environments and noise levels. The role of health surveillance in noise-exposed environments is crucial for maintaining the well-being of workers. It should be systematic and regular, typically taking the form of audiometry. Health surveillance is especially important for workers potentially exposed to noise levels at or above the 85 dBA exposure limit as established by occupational health and safety standards. Additionally, individuals with known hearing damage at lower noise levels should also undergo health surveillance. Audiometric testing, a fundamental component of health surveillance, is a medical examination that quantifies the sensitivity of a person's hearing across a range of frequencies. This testing helps identify any changes in hearing ability, enabling early intervention and appropriate measures to prevent further hearing damage in a noisy work environment.